Hello everyone and welcome to our week 4. I hope everyone's doing well and enjoying your week so far. So the agenda for today is to talk about the concept of loops in Python. I will begin by doing a PowerPoint presentation on loops, then go over some code examples. I will also go over the week 4 module quickly, and of course I will go over the week 4 Python assignments in details. Now I will also cover the random library as well as the range function, so let's get started. So loops in Python, as well as in any programming language really, are essential control flow structures that allow the execution of a block of code multiple times, which reduces the need for manual repetition. And Python supports two main types of loops: for loops, which iterate over a sequence of items, such as a list or a tuple or a string. Then we also have the while loops, which continue to execute as long as a specified condition remains true. And as you might have guessed from the name, these loops are fundamental for tasks involving iteration, such as processing items in a collection, automating repetitive tasks, and handling dynamic data. Also, Python provides control statements like break, continue, and else within loops to manage their execution flow more precisely. So I'll start talking first about the for loops, and then move on to while loops. Okay, so in Python, a for loop is used to iterate over a sequence of items such as a Python tuple, list, string, or a range, which we'll talk about today. The loop's job is to execute a block of statements for each item in the sequence. So let's get a couple of terms out of the way first. A sequence of items that you can iterate through is called an iterable, or an iterable object. And as we iterate through the items one by one, we create a temporary variable called the iteration variable. Now this variable will change value each time it iterates in the loop. And one key component of a for loop is that the number of items in the loop is predetermined. So this means that you know when the loop will start and when it will end. So we will loop for a known amount of times. And the flow of the for loop is shown in this picture here. We loop for each item in our sequence, and the first question to ask is, have we reached the last item in our sequence yet? If no, then we enter our loop and run any statements we have in our indented code. Then we run the indented code, then we loop to the top again, and then we ask ourselves one more time, have we reached our last item in the sequence yet? Meaning, have we finished looping through all the items? And if the answer is no, then we loop to the top, take the next item in our sequence of items, set it as the iteration variable, then run the indented code once again. However, if we have reached the last item in our sequence of items, then our iteration effort is done and we exit our loop. So this is the structure of a for loop. We start with the for word, which is a reserved word, followed by the iteration variable, followed by the word in, which is another reserved word, followed by the name of the iterable object, then followed by a colon. And then under that is our indented code, which will run as long as we still have items in the sequence to loop through. So this structure is somewhat similar to an if statement, where we have the header line to check an expression, and if it's true, then we enter the indented code. But if it's not true, then we don't run the loop and go to the next line of code that is after the loop. Now in Python, for loops are also flexible, that we can exit the loop before we iterate through the entire list of items. For example, say you are iterating through 100 items, but if you reach an item with a specific attribute or a specific value, you may want to stop the loop for some reason. So in Python, a break statement is used within loops to terminate the loop prematurely when a specific condition is met. When the break statement is executed, the loop stops its iteration, we exit the loop completely, and control is transferred to the statement immediately following the loop. This is particularly useful for stopping a loop when a desired result is achieved or an error condition occurs, allowing for more efficient and controlled looping. Also in Python loops, we can have a continue statement. Now the continue statement is used within loops to skip the current iteration and proceed directly to the next iteration of the loop. So when a continue statement is encountered, the loop's remaining code for the current iteration is not executed, and control is transferred back to the beginning of the loop for the next iteration. This is particularly useful when we want to bypass certain parts of the loop under specific conditions without exiting the loop entirely. which helps to allow for more precise control of loop execution flow. Alright, let's switch gear now and talk about while loops. Now in Python, a while loop repeatedly executes a block of code as long as a condition is true. So the condition is checked before each iteration of the loop, and if the condition evaluates to true, the code block inside the loop runs. Now once the condition evaluates to false, the loop stops executing and the program continues with the next statement following the loop. So we can say then that while loops are useful when the number of iterations is not known beforehand, and the loop needs to continue until a specific condition changes. And within a while loop, the condition can involve any type of logical expression, including comparisons, function calls, and variable states. Now this flexibility allows for a wide range of applications, from simple tasks like counting, to more complex processes like reading data until a certain input is received. But please be careful. Special care must be taken to ensure the condition will eventually become false. Otherwise, the loop can become an infinite loop, running endlessly and potentially causing the program to hang or crash. So to avoid this, it's common practice to include statements within the loop that modify variables involved in the condition, and this ensures that the loop progresses toward termination. And I will show you an example of an infinite loop and how to evade it. This image outlines the basic structure of a while loop in Python, which emphasizes key components and their roles. So the while keyword is used to initiate a while loop. It signals to the Python interpreter that the following condition should be evaluated repeatedly to determine whether the subsequent block of code, which is the body of the loop, should execute or not. Then, right after the while keyword, we have the condition. This can be an expression which evaluates to either true or false. And this condition is checked before each iteration of the loop. And if the condition is false, the loop terminates and the program proceeds to the next statement following the loop. Then we have the colon at the end of the while line. This is a syntactical element that indicates the start of the indented block of code, which constitutes the loop body. The colon is a fundamental part of Python's syntax for defining the beginning of blocks of code that belong to control structures like loops, functions, and if statements. Now after the colon, the diagram shows that the loop body consists of one or more statements that must be indented to denote that they are part of the loop. This indentation is crucial in Python because it indicates the scope of the loop. Now the loop body will continue to execute as long as the condition remains true, and each time the loop body runs, the condition is re-evaluated before the next iteration begins. Now I can't emphasize enough the importance of indentation because it is a fundamental aspect of Python syntax. Proper indentation signifies which statements are part of the loop body, and without correct indentation, Python will not recognize the statements as part of the loop, which could lead to syntax errors or logical errors in the code. This diagram illustrates the flow of a while loop in Python when using the break statement. So here's the process step by step. The process begins at the start oval point, which leads to the evaluation of the loop condition. This is step 1, where the condition of the while loop is evaluated. Now this condition determines whether the loop body will execute or not. If the condition is false, the loop is exited and the flow moves to step 5, then step 6. But if the condition in step 1 evaluates true, then the body of the loop is executed in step number 2. The body contains the statements that should run with each iteration of the loop. Now, within the loop body, if a break statement is encountered, as seen in step number 3, Python immediately terminates the loop, bypassing the condition check for further iterations. This sends the control flow directly to the loop exit point, which is step number 6. But if a no break statement is encountered, after executing the loop body, the condition is reevaluated to determine if another iteration should occur, which is step 4, that loops back to step 1. So this diagram highlights the critical role of the break statement in altering the normal flow of a while loop. Now the break statement provides a way to exit the loop prematurely, regardless of the initial loop condition, which can be useful for scenarios like finding a specific item in a list, handling exceptions, or responding to user input dynamically. Okay, so this diagram illustrates the flow of a while loop in Python when using the continue statement. We begin at the very top with the start oval, which then leads to the evaluation of the loop condition. So this is step 1, where the condition of the while loop is evaluated. Now this condition determines whether the loop body should execute. If the condition is false, the loop exits and the flow moves to step 6. But if the condition evaluates to true, then the loop checks for the continue statement as seen in step number 2. And if a continue statement is encountered, the loop skips the remaining statements in the loop body and goes directly to the next iteration, which reevaluates the loop condition as seen in step number 4. But if no continue statement is encountered in step 2, then the loop executes the body of the loop as seen in step number 3. This includes all the statements that are intended to run during each iteration of the loop. So to sum this up, the continue statement in a while loop is used to skip the current iteration and move directly to the next iteration by re-evaluating the loop condition. And this can be useful for situations where certain conditions within the loop should cause an early jump to the next iteration, effectively bypassing the rest of the loop body for the current iteration. So let's sum up the difference between the two loop types. This table compares for loops and while loops, highlighting their primary differences and typical use cases. So purpose-wise, a for loop is used to iterate over a sequence of items, such as list, tuple, or any iterable object. It is designed specifically for iterating over a predetermined sequence. As for design purposes, for loops are intended for situations where the number of iteration is known beforehand. They require a sequence to iterate over, making them ideal for fixed length operations. And as for efficiency, when iterating over sequences, for loops are often more efficient than while loops because the number of iterations is predefined. This allows the loop to be optimized for performance. And now let me switch to while loops. Purpose-wise, a while loop is used to repeatedly execute a block of statements as long as a specified condition remains true. Now this type of loop is more flexible in terms of its control flow. As for design, while loops are used when the number of iterations is not known in advance, or when a block of code needs to run until a certain condition is met. So while loops require an initial condition that is tested at the beginning of each iteration. As for complexity and efficiency, while loops are more suitable for complex control flow situations where conditions might change in unpredictable ways. They can be more efficient in cases where the condition being tested can be evaluated quickly, even if the exact number of iterations is not known from the start. So overall, the table shows that for loops are typically preferred for straightforward iterations over known sequences, and while loops offer more flexibility for dynamic and condition-based iterations. Now the choice between the two depends on the specific needs of the task at hand, such as the predictability of iteration counts and the nature of the condition that is driving the loop. This slide demonstrates a while loop in Python for user validation, specifically for password entry. So the loop starts off with the condition while true, and since true is always true, then this while loop will always run, at least once, until something inside of the loop breaks it. So the loop runs indefinitely with while true, prompting the user to enter their password. Then the entered password is validated by the isValidPassword function, which takes one argument, the user's entered password. Now this function should have some requirements check to validate that the password meets all of them, like how many characters and what type of characters. Now if the password is valid, then the loop exits with a break statement. But if the password is invalid, then the loop prints out the message, invalid password, try again, and then continues to prompt the user once again. So this process repeats until a valid password is entered, ensuring continuous validation and user feedback. So again, the while true condition is a way to run the loop at least once, but please make sure to include some logic in the body of the loop to break out of the loop, otherwise you will have an infinite loop. This slide presents an example of a while loop used in the context of event handling within a game application. So the loop runs as long as the condition game is running is true, and within this loop, 3 functions are called sequentially: handle events, update game state, and render game. So first, the handle events function is responsible for managing user inputs and other events, ensuring that the game responds appropriately to user actions such as key presses or mouse movements. Secondly, the update game state function updates the game's logic, which includes modifying the game's data and state based on the events handled in the previous step. This could involve updating the position of game characters, checking for collisions, or advancing to the next level. And finally, the render game function is called to draw the updated game state to the screen, providing visual feedback to the player. So this loop continues to execute these steps in sequence until the condition game is running becomes false, typically when the player exits the game or a game over condition is met. This structure ensures that the game remains interactive and responsive to user inputs while continuously updating and displaying the game state. This slide illustrates the concept of dynamic data processing using a while loop to read and process data until the end of the file is reached. The loop operates under the condition while not end of file, meaning it continues to run as long as the end of the file has not been encountered yet. Now within the loop, we have the read next line function, and this is called to read the next line of data from the file. This data is then processed using the process data function, which handles the necessary operations on the data, such as parsing, analyzing, or transforming it. And following the data processing step, the loop includes a conditional check if condition met. Now this condition evaluates whether a specific criteria related to the data has been satisfied. If the condition is met, the variable end of file is set to true, which causes the loop to terminate. This setup allows for flexible and dynamic processing of data, where the loop continues to handle data lines sequentially until the defined condition signals the end of processing. And this approach is particularly useful for scenarios such as reading log files, processing streams of data, or handling large data sets that need to be processed incrementally. This slide shows a for loop, and in the provided code snippet, we see a list named numbers, which contains the integers 1 through 5. The intention is to calculate the sum of these numbers using a for loop. The for loop is a control flow statement that enables the code to iterate over each item in the list. So during each iteration, the current number is intended to be added to a running total called sum result, which in this case would be 15. Now, there's a built-in function in Python called sum, which you can just pass it a list as an argument to get the total sum, but I just wanted to show you a simple for loop as an example to iterate through a list of numbers and then add them together to give you the total. Alright, in the code provided here, we see a for loop, which again, as we know by now, is a control structure that allows a block of code to be repeated a certain number of times. Now this loop here uses the range function to create a sequence of numbers from 1 to 10. And for each number in the sequence, the loop's body, which contains the print I statement, is executed. The print I statement outputs the current number to the console to demonstrate how the loop iterates through the entire range. Now this example is a straightforward demonstration of fixed iteration, where the count is predetermined by the range specified. Again, it's a fundamental concept in programming that enables developers to perform repetitive tasks more efficiently. So the concept of fixed iteration is essential in many programming scenarios. For example, as in processing items in a list, or generating a series of numbers, or simply repeating an action a specific number of times. Understanding this concept is crucial for anyone learning to code, as it forms the basis for more complex operations and algorithms that one might encounter in the field of software development. In Python, there's the random module, which is a powerful library that provides tools to generate random numbers, select random items from sequences, shuffle data, and perform various other operations involving randomness. It is widely used in various applications, including simulations, games, testing, as well as security. And you can see from this slide that the random module comes with a slew of methods. I will talk about a few of them, like the random method, the randint method, and the randrange method. But please do look up the other methods yourself and learn more about them. Okay, so let's delve into an exciting feature of Python that opens up a world of possibilities, the random method, from the random module. Now this nifty method is quite straightforward. It doesn't require any arguments, and it just generates a random floating number between 0 and 1. Now you might wonder, why is that even useful? Well, imagine you're creating a game and you need to simulate dice rolls, or you're conducting a simulation where outcomes need to be unpredictable. So the random method is perfect for these scenarios, and it's incredibly simple to use as well. All you need to do is import the random module in your code, then just call random.random, and voila, you have a random number at your disposal. So as you can see, with just a couple lines of code, we can introduce randomness into our programs, making Python a powerful tool for developers and researchers alike. Now, if you don't want to generate a floating number between 0 and 1, but instead you want to generate actual numbers like integers, then the randint method is the way to go. It takes two arguments, start and stop, so you can control what numbers are returned. And the stop argument is actually included in the number generation. So in the code example provided here, we start at 3 and stop at 9. This means that the randint method can return a random number as either 3, 4, 5, 6, 7, 8, and also 9. So the randint method is a versatile and easy to use tool that can be employed in a variety of programming tasks which require random integer generation. Its straightforward functionality and the inclusive nature of the range make it a go-to choice for developers needing to introduce an element of randomness into their Python applications. Now, if you want a bit more control on your number generations, you can use the randrange method. This works pretty much like the randint method, but in addition, there is a third argument called step. So you still provide the start and stop arguments, but with the step argument, you're adding incrementation. So if I use the same start and stop as before, like 3 and 9, but then I add a third argument with a value of 3, then I will start at 3, then step or increment to 6, then step to 9. So this gives me more control on what numbers to include and exclude in my random number generation process. And you can also see in the middle of our screen that both the start and step arguments are optional, while the stop argument is the only required argument. For example, if I just have the randrange method with one argument, let's say 6, then Python will default to a start value of 0 and a step value of 1. Again, these are the default values if these values are not specifically provided as arguments. Alright, so I've been talking a lot, and now it's time for some code examples. So this code file is basically all about the random library and the different methods that come with it. Now, of course, there are more than just these 4 methods, but I just wanted to give you a sample of what type of methods and how they run. So I'm going to comment out just the last 3 lines and go line by line. The random method basically just returns a floating number from 0 to 1. So if I run this code once, I get a random number generated. Again, between 0 and 1, and it's a floating number. If I run it again, I get another randomly generated floating number between 0 and 1. So that's all what this random method does. It just generates a number, a floating number, between 0 and 1. So let's comment this out again. Let's bring this guy in. So the randint is a little bit different than random. And randint basically is going to return a random number between 3 and 10, including 3 and 10. Well, let's run it a few times and see if that's the case. So if I run this, I get 3. So now we know that 3, which is the start argument, is included. Let's run this again. I get 7. So 7 is between 3 and 10, so it's included. Let's run it again. I get 4. Let's run it again. I get 8. Let's run it again. I get 4 again. Again, it's a random generation of numbers. Okay. And there you go. Now 10 is also generated. So this basically tells us that the start number and the stop number, both of them are included. Okay, and this is just proof that Every time we generate a number, we get a different number, but not any random number. It's a number that's from 3 to 10, including 3 and 10. So that's what randint does. Let's comment this guy out. Let's bring this in. So the rand range basically works kind of the same way as randint, but we have a third argument that's added. So the first argument is the start, the second argument is the stop, and the third argument is the step. So the rand range method is going to randomly generate a number that can be any number from 0 to 10, including 0 and 10, but it has to be increments of 3. So if I start at 0, I'm not going to get 1 or 2 back. I could get 3. I'm not going to get 4 or 5 back. I might get 6. I'm not going to get 7, 8 back. I might get 9. Okay, why is that? Well, because I'm specifically said that I want to use not every number from 0 to 10, but only increments of 3. All right, so let's test this out. I got 0, okay, because that's the start. Let's run it again. I got 6, so 6 is a correct random number because it comes in steps of 3. So again, 0, 3, and 6, and 9 would be possible random numbers. So let's keep running it again. 6 again. It's okay to get duplicate numbers, it's random numbers. 3, I'm trying to see if I can get a 9. Okay, 0 is also possible because it's starting point. There we go. So here is 9. So again, starting at 0, including 0, ending at 10, including 10, but increment at 3. So that's why we're never going to get 10. We're only going to get increments of 3 starting at 0. Let's comment this guy out. Let's bring this one in. All right, now the sample method basically takes a sequence of items, which could be a list, and it's basically going to sample a certain number of items, and that certain number is in the second argument. So the sample method takes the first argument, which includes the sequence or the list of items, and then the second argument is going to say, well, how many sample items do you want to return? Okay, so now I have a list of 1, 2, 3, 4, 5, 6, 7, and I want a sample of 2. So this is going to randomly choose 2 items from this list. So if I run this, I get a list of 3 and 6. So that's a sample of 2 from this list here. Let's run it again. I get another random sample, which is 7 and 4. And if I run it one more time, I get another random list, which is 6 and 2. So this is what the sample method does. And again, these are just 4 methods which are part of the random library. And again, there are many, many more. So please explore them by going through the Python documentation. Now I wanted to talk about the range function, which is a built-in function in Python, mainly because it's used a lot with for loops. So I'm not going to show you any for loops in this code example. I'm just going to talk about the range function itself. Okay, so if I comment this out, this basically says print for me the range 0, 10, and 1. And as the text up here it says, the range function returns a sequence of numbers starting from 0 by default and increments by 1 by default, and then stops before a specified number. And the syntax for it is use the range, the name of the function, followed by the start argument, then the stop argument, then the step argument. Okay. Now, a lot of people say, okay, I can basically say range and then say 0, 10, and 1, and that's going to return for me the actual numbers. Well, let's test this out using a print statement and see what happens. So I just have a print statement. I'm going to pass it the range of 0, 10, and 1. So technically then I should get the numbers of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't include 10 because again it says stops before a specified number. So 10 is not going to be included. So I'm going to guess that the range method is going to return all these numbers for me. So let's run this and see what happens. Alright, all I get back is range 0 to 10, which is not what I expected. But that's the correct output. So if you want to see what sequence of numbers get returned from the range function, there is a way to unpack all the sequence of numbers. And the way to do that is using the star sign right before the function name. So let's comment this out and let's bring this in. Alright, so I have a print statement and the print statement is going to pass this text followed by a star and then range 0, 10. Okay, so I know that 0, 10, the sequence of numbers included in 0, 10 are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but I want to print it out just so I can get a confirmation for it. And the way to do that is not just say range 0, 10, but to do a star or an asterisk range 0, 10. So if I run this now, Python unpacks all the numbers that are part of the range 0, 10 function call. Okay. All right, so now that we know that the first argument is going to be the start and then last argument is going to be the stop, then the output is going to be 0 all the way through 9. Okay, and just to confirm also, let's do another example. This time I'm going to do a range 1, 10. So technically I should get starting from 1 and not include 10, but stopping right before 10. So it should be 1 through 9, just like I have here. This is the comment part. So if I run this, F5, range 1, 10 is going to unpack or includes numbers 1 through 9. Doesn't include 10 because we stop before the stop sign. All right. Now let's bring in another code example. This time I'm going to pass not just 2 arguments, but I'm going to pass a third argument, and the third argument is the step. So I'm going to start at 1, I'm going to stop at 10, meaning not include 10, but only stepping through by 2s. So if I start at 1 and step by 2, then next number is going to be 3. And then from 3, step by 2, I'm going to get 5. And then step by 2, I'm going to get 7. And then step by 2, I'm going to get 9. And that's where I stop because the ending is 10. So I should get back 1, 3, 5, 7, 9. All right, so basically what I'm trying to get is I just want to show you what this function holds as sequence of numbers, just so you can understand. All right, so if I run this code, F5, I get as expected. Range function that has starting point 1, stopping at 10, increment at 2, it will actually include these numbers here. All right, now we can also do backward flow. So if I get rid of, all right, so if I say range 25 to -2, well, I'm going to start at 25 because that's what this argument is. We're going to stop at 2, and then for my step I have a -2. So negative means you go backwards. So that means I'm going to start at 25. You can see here, I'm going to start at 25, that's my starting point, and then increment by or step by -2, so make it 23, and then backwards another 2, be 21, 19, 17, and so on and so on. So that's what the negative in a step argument mean. And if we test it out, that's exactly what I get. All right, I go all the way to, I stop at 3 because my stopping point is at 2. So if I would continue from 2 using -2, I would go down to 0, or technically, sorry, go down to 1. That's the next increment by 2. But 1 is not part of 25 to 2 range. Okay. Now the range function only takes integers. Okay, so if I bring this guy in and I try to do a range of 5.5, which is a float, this will generate an error. So let's see that in action. There we go. So I get a type error, and the message is float object cannot be interpreted as an integer. Okay, so the range function is expecting integers for arguments. All right, let's comment this guy out again. And let's bring this one in. Now this says print the unpacked sequence where we start at 1, stop at 10, and increment by -1. Now the reason I wanted to show you this example is because I want to show you the error. So let's comment that back in. Let's run this. And nothing happens. So I didn't get an error, but I did not get any value back. Now the reason is because if we look at this and try to understand it based on what we've learned and based on the arguments, so this says basically this is going to hold a sequence of numbers that starts at 1 and then stops at 10. But we're going to be going in the -1 direction. So -1 meaning that we're going to go backwards, incrementing by 1. So if I go from 1 to 10 negatively, meaning in the opposite direction, so that means I'm going to go 1 and then 0, -1, -2, -3, and so on. but my numbers that start and stop are from 1 to 10. So there are no numbers to unpack or are part of the sequence using these arguments. And the reason why I had a testing after here just is to show you that the code is still running. Okay, so this print statement is going to generate nothing, and then the print statement here is just going to generate the string testing after. So if I run this again, F5, okay, nothing was generated on this line, but then I get the testing after. So again, I just wanted to show you what this range function does, because you will be seeing it a lot or working with it a lot when we do for loops. In this code example, I'm basically going to show you a while loop and a for loop. And you're going to see that the output is exactly the same thing for both loops. So you can do the same thing using two different loops. One is going to be more efficient than the other, and we're going to find this out now. So beginning with the while loop, I start by defining a variable called product set equal to 1, and then I have another variable called number set equal to 1. And then I have my while header, or my while rule, and what I'm saying here is while number is less than 11. Now as long as this rule answers to true, then I'm going to run this indented code. Okay, now number so far has been defined as 1. So while 1 is less than 11, yes, that's true, then run this code. Now what this is going to do is it's going to take product, which right now I define as 1. It's going to take product, which is 1, multiplied by number, which is also 1. This is on the first iteration. Okay, so 1 times 1 is going to be 1, which is going to be assigned to the value product. Then I'm going to print whatever that value is, which is 1. Next, I'm going to increment my number value, which so far is just 1. I'm going to increment it by 1. This is the shorthand to increment, or you could also do it this way. Number equals to number plus 1. So this is how we can increment a variable by 1. This is the longhand version, and this is the shorthand version. And when I increment the number by 1, again, number on the first iteration was 1. Now I'm going to increment it by 1, so now number is going to become 2. And then we go back to the top of the loop again. While 2 is less than 11, that's true, so I'm going to run this code. And then I'm going to increment number by 1. So it used to be 2, now it's going to be 3. Then we loop again to the top. While 3 is less than 11, that's true, so I'm going to enter this. So this is going to keep running and running and running, and every time it runs, it's going to increment the number variable by 1. So we go to 3, and then run again, then 4, run again, 5, run again, 6, run again, and can keep going and going and going until number if number is 10, 10 is less than 11, that's true, then add 1 to it, becomes 11. While 11 is less than 11, no, that's not true. So that means the while loop will stop to run, because the rule here, while number is less than 11, is not true anymore, because 11 is not less than 11. 11 is equal to 11. So the while loop is going to stop running, and we exit the indented code and then move on to the next line of code in our code file. So actually, before I talk about the for loop, let's run the while loop. So let me comment this out and see what happens. F5, and there we go. So we get, on the first run, I get a 1, and then a 2, and a 6, 24, and so on, so on, so on. But it only ran 11 times. Okay, actually it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Okay, because we didn't make it to 11 times yet. All right, but the reason why this while loop ran and then stopped is because there was the number value, or the number variable, kept changing and incrementing to a point where this statement eventually will become false. All right, now if I comment this line out, okay, then while number is less than 11, what is number? Well, number is 1. Okay, so while 1 is less than 11, that's true. Then I'm gonna run this code and then go back to the top again. While number is less than 11, well, what's number? Well, number is still 1. Number value has not changed, it's still 1. So while 1 is less than 11, that's true, then run this code. Then go up again. while 1 is less than 11, that's true, then run again. While 1 is less than 11, still true, then run again. So this is what's going to lead us to an infinite loop. And the reason why is because the while loop will continue running as long as this condition is true, but nothing is changing in my code to change this to false at all. So if I run this code now, as is, look what's going to happen. If you can see the spinning beach ball, that means my computer is overworking, and it's just, I don't see my output for some reason, but you can guess that the machine is overloaded and it's just going into an infinite loop. So I have to terminate this program. And you can see here that my program is not responding. So I'm going to force quit. So again, anytime you want to use a while loop, just make sure that you have some logic in your code that will eventually make this statement a false statement, so you don't enter into an infinite loop. All right, let's comment this out. Let's bring in a for loop. Okay, so this for loop does exactly the same thing as the while loop, but in a for loop scenario. So I'm going to start with a variable called product equal to 1. Then I'm going to have a list of numbers or a sequence of numbers in a variable called numbers. And the sequence of numbers are going to be based on the sequence of numbers that I get back from this range function. And we learned about the range function a few minutes ago. So this range 1, 11 basically is going to return a sequence of numbers that starts at 1 and stops at 10, not 11, doesn't include 11, and it's going to be incrementing by 1. So this is going to be basically, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, that's what range 1, 11 unpacks to these numbers. Then we come to the for loop. So the for loop is going to use the for keyword followed by an iteration variable. So this variable, you can call anything you want. In this case, it's called number. This variable is going to be on the first iteration, it's going to be the value 1. On the second iteration, it's going to be a value 2. Third iteration, 3, and so on. And it's going to keep looping one by one every time it takes a different value. And once it's done, there are no more items in the sequence, then we exit the loop. So the for loop, as opposed to the while loop, kind of has a built-in anti-infinite loop mechanism, because it's only going to run a certain number of iterations based on the certain number of items. So this makes it more efficient, and I also don't have to include logic in my for loop that basically says, you know, change number to a value that eventually is going to make this statement false, like we did here in the while statement by using an increment of a variable. I don't have to do this in my for statement. And if I run this code, F5, I get exactly the same output that I did with a while. So again, the difference between for and while, for we know how many times this is going to run for, while is going to continue running until this rule becomes false, which can lead us to infinite loops if we don't write the logic correctly. Okay, so let me close this now and go back to our module 4. It basically gives us access to a lab 2 that we have to download, and when you click on that, it opens up into another window and provides us with 2 files, policies.csv and a Jupyter Notebook file. Okay, so please download both of them. Then I have opened the Jupyter Notebook basically in VS Code, and again, just like previous Jupyter Notebooks, just please make sure that you read all the details in it and follow it step by step. Now this part of the Jupyter Notebook talks about modularization, which basically means creating functions or components or grouping your code so that you could handle it easier and be cleaner and functions better. And down here we have the code from last week, and basically just made up of one function, we can see here, and then a bunch of code. And then the text here basically says that we defined one function, but there are a couple other opportunities to use functions that we missed as well. So if we look at the code up here, we basically have one function and then a bunch of code lines. Now, if you just look at it from a categorical perspective, well, you can say, okay, well, perhaps I can put this bunch of lines of code into one function and then maybe group this into another function as well. All right, so that's what it's talking about here. And then says, here's what it would look like if we do this. So if we scroll down, we now have the original handle request function. This hasn't changed, but then anything that had to do with the checking the username, we basically put it into its own function. And then the chatbot as well, where we say what's your name, and then we asked if you want to do another request. We put that into a separate function. So now we have 3 functions instead of just having one function, and then the rest of it is all just a bunch of unrelated code. And then we come to our very first challenge, and it's asking us in the code box below, rewrite the chatbot from above, but remove the functionality for checking the name of the user. Remember to remove any reference to checking the user's name. So basically what we need to do is come up here, let's click, and I'm going to do a Command A or Control A to highlight all the code, and then a Command C to copy it. And come down here in this code cell, I'm going to do Control V to paste it. Okay, so now I just copied the code from here into the challenge code cell here. And it says to remove any functionality that has to do with the name of the user. So now that we have a function called checkUser, this is the function that we need to get rid of. Remember, a function, when it's defined, so this is just the definition of a function, this is useless unless some code calls the function by its name. So if you check any code here that calls the checkUser, you're basically going to find it here. Okay, so I need to comment out this line, and if I comment out this line, then basically it's going to not call this function here. So I'm going to comment this line out, and anything that has to do with the name also, so comment this line out as well. Now notice here that the rest of this code was indented as part of this if statement, so I could now outdent it so it's no longer indented under the if statement. Okay, now technically you can stop there, but since you know that you're not going to be using the checkUser function, then we can also comment this entire block of code out, because we're not going to be using the checkUser anymore. And if we scroll down here, okay, now if that works successfully, then your chatbot should have 2 functions, handle request and chatbot. Okay, so here is handle request, this is commented out, and here's chatbot. So far this looks good, and should ask the user what the user wants help with twice. Okay, so let's run this and see. What would you like help with? So let's do vacation, and down here you're allowed 15 vacation days. Okay, is there anything else you'd like help with? I'm just gonna say yes, and then contact, hit enter, and there we go. It ran twice and stopped. So far we are good. Then it says, what if we wanted to learn about all 3 different policies? Well, we could do another if-else statement inside the chatbot. So here we have the different if-else statements. If vacation, do this. If it's contact, do that. If it's location, do this. Else, do that. All right. So that's good. But what happened if we had 100 policies? Are we going to ask 100 questions or 100 if statements? Well, that's not really very efficient. And so we've learned about loops already, so we could start to incorporate loops into our code. Now here is a loop that we can use for our problem. Basically we say while true. So while true basically is a true statement forever until something makes this true a false. So while true, yes it is true, true is true, then enter this indented code and run it until something breaks out of the block. And so if we look at this code line by line, once this is true, which it is, we're going to prompt the user, which would you like help with, vacation, contact, location, or exit. And then we have the if statements. If request is vacation, do this, and so on. And then down here, if you notice, we have a new option, which is exit. And if that user does type exit, then we're going to print thank you for using this chatbot, and then we're going to break. So the break, what we learned before from previous weeks, is that it's a way to exit out of the while loop. It basically turns a true into a false. So if you run this, what would you like help with? Let's do vacation. Okay, let's do vacation again. Let's do contact. Let's do location. So it keeps running the loop until something exits out of the loop. And thankfully we have an exit option. If I hit enter now, then we exit out of the loop because we broke out of the loop. Okay, so this is a nice while loop to help us with our code. Now for our next challenge, it says in the code below, rewrite the full chatbot code, but this time use the code from above, which is this while loop. Use the code from above as the contents of your handle request function, and note that you shouldn't need to explicitly ask for another request in the chatbot function anymore. So let's take the first step of copying the code that we had from before, which is this guy here. I'm going to click on it anywhere, do a Control A or Command A, and then copy it, Command C. Scroll down here to the challenge code cell, paste it, and then in our handle request, we are going to change, copy all that, copy the loop as is, and then replace the existing code here with this loop. So I'm going to erase this code, and I'm going to paste the loop that I just copied from above. Now you might need to do some cleanup work for the indentation to work, so let's see if we can do that quickly. There we go. Now indentation again is very, very important in Python, so make sure that you have everything lined up correctly. So in the definition, we indent for the next line, which is a while loop, and then anything in the while loop needs to be also indented. And the next update to this code is that now that we have this while loop, then I don't need to ask the user for another attempt to run this code. So I'm going to comment out this code, and basically, yep, the only thing left really is just the chatbot function is just going to call the handle request function. Okay, so if you implemented the last challenge correctly, your program should be looking pretty efficient, around 18 lines of functional code. All right, let's double check. Are we on the right track? So we have this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So pretty close, okay? Now, when you comment out code, technically it's not going to be used. So you could, if you want, you can delete the code, or you can just keep it commented out as you like. It all depends on you. Me personally, I like to keep it commented out until I test it and everything works fine, and then I start deleting code. But that's how I do things. You could do it differently as you like. All right, let's move down. It talks about data types. So here it's going to talk about using dictionaries for our data. And basically here we have a dictionary called responses. And again, dictionaries are basically key value pairs. So here's the first key and its value, next key, its value, last key and its value. Okay, and again, this is a dictionary because first of all it's in squiggly braces, and then key value pairs, and we separate them by colons, and we separate the key value pairs from each other by commas. The very last one, you don't need a comma. Okay, now to call on the value of any key, you basically say print and then call the dictionary name, use square brackets followed by the name of the key that you want to call. So if I run this code, again, I'm defining a dictionary with all this data in it, and then I'm going to print out not all the dictionary, but just the value of the contact key. Here's contact, so its value is this. So if I run this block of code, I get you can contact HR at so-and-so, which is correct. All right. So we come to our next challenge, and it says in the code below, rewrite your chatbot program again. So I'm going to copy and paste from above. Let's do that now. Okay, click on the code, highlight all of it, copy it, come down to the challenge cell, paste it. Okay, and let's see what the instructions say. So copy the chat program, defining a dictionary of policies at the top of your code. All right, so at top of our code, I'm going to come here to this code cell, highlight all, copy it, come down here, right before my first definition of a function, I'm going to paste it. So now I have a dictionary of responses. And then it says, then updating your handle request function to access relevant information for user's query. Remember to keep checking if a user wants to exit the program. You don't need to add an exit to your dictionary. So now that I have my dictionary up here, I need to come down here, and then in the handle request function, I don't need all this anymore, because all this is going to be replaced with the use of my dictionary. So I'm going to replace this with saying if request is equal to, if request is in responses, okay, and responses is this dictionary, then I want to print out, well, actually, I just need to copy this. Actually, I'm going to cut it because it doesn't belong here. I'm going to cut it, so Control X, come down here. So if request is in responses, colon, enter, indented, and then paste. All right, so what this is going to do is, request is whatever the user enters here, vacation, contact, location, exit. So vacation is here, contact is here, location is here, and each has its own value. So if request is in responses, so whatever I type here, if it's part of this dictionary keys, then it's going to print the responses followed by, actually this needs to be replaced with request. Okay, so the responses is the name of the dictionary, and then request is the name of the key. Now, which key is it? Well, whatever the user types. If the user types vacation, it's going to find the vacation here if it's in responses, and it's going to print the value. If the user types contact, then it's going to find in the responses dictionary the request, which is this time is contact, so it's going to go up to that dictionary and find contact, and then return the value of that request key. Okay, so I was able to shrink my code into just this one if statement and using the responses dictionary. And just to confirm, let's run it. Okay, which would you like? Let's try vacation. Hit enter. Oh, okay, so basically I think I added, yeah, there we go. I don't need a, this is a variable, not a string. Request is this variable here. Okay, let's try this again. Run it. Vacation, hit enter. Okay, scroll down. Yep, I got the right output. Let's try contact. Enter. Yep, right output. Location. Enter. Yep, right output. And let's exit. And we're done. Okay, so this code seems to have run correctly by adding this dictionary and using it in this if statement. And it's dynamic enough because it's getting the data from here. So I don't need multiple if statements anymore. Let's go to the next part. Okay, files. Now, it's nice that we have multiple items we can use here. But again, it's not very best programming practices to have your code in the file. You want to have your data basically outsourced somewhere else, like in a file. Okay, now there are different ways we can work with files in Python. One of them is we can use the pandas library, which we talked about earlier. So the assignment gives us an access to a policies.csv file. All right, that's one of the two files that we downloaded here. Okay, now let me open up this policy.csv file. I'm going to open up in a text editor. So this file actually needs to be edited just slightly because it doesn't conform to proper formatting, meaning that some of the values don't have double quotes. So I'm going to add a double quote here, and also misspelling. Here is a misspelling as well. Insurance. And it also needs to be surrounded with double quotes. And this needs to be double quote. And this needs to also end in a double quote. All right, so all the values are surrounded by double quotes now. Double quotes and double quotes, double quotes. Correct. So that takes care of that. Make sure you just make this update before you start working with a file. And here now in the next code cell is saying that we're going to be using the pandas library, and when you use an outside library or a module, you need to import it using the import keyword followed by the name of the library. So I'm going to say import pandas. Okay. Now again, pandas allow us to work with data sets, and here is a function that basically says, well, it's called load underscore responses underscore from underscore CSV. It takes one parameter called file name, and what it does is it calls the pandas library, and inside the pandas library we have a method called read underscore CSV, which, as you can guess, it's going to read data from a CSV file. We pass the file name here, and what this is going to do is it's going to create a panda data frame, and what that data frame is going to be assigned to a variable called df, which is a variable name that you can make up, but df is short for data frame. Again, you can call it anything you want. This is a variable name, but what this does is it takes data from a file, It reads data from a file and then dumps it into a Panda data frame. We assign this data frame into a variable called df so we could use it. Now, I'm going to create another variable called responses, and it's going to be assigned to the same data frame that I just created, but I'm going to convert it to a dictionary. Why convert it to dictionary? So I could use it in my code, my Python code. Dictionary is a data type. Data frame is not a Python data type. So I'm going to convert all this data from the data frame, which is data from the policies file. I'm going to convert it to a dictionary using the to_dict method. So again, that's how powerful Pandas is. You could take data, you could convert it, you can read from it, you can dump it to a database, you can do so many things to it, just with a few lines of code. Now, this method here, the setIndexTo, remember Pandas uses indexes, which are labels, and it uses by default the 1, 2, 3, 4, and so on. But I don't want to use numbers 1, 2, 3, 4 as my index values. I want to use the actual keyword, which are these guys here. This is what I want to make the index as my keywords, and then the responses are going to be the values here. Okay, so that's what this line of code does. It's going to set my index to use the keyword and response combination from the data frame that I created from this file, which is going to be policies eventually. And then whatever this data frame is, after I have modified it to use the correct syntax at the correct index, then I'm going to convert it to a dictionary and then assign all that data to a variable called responses, then print out or return the responses to the function call. So that's the definition of the function and what it does. This is going to be pointless if I don't call it. So down here in my regular code, I'm going to call this function. I'm going to pass it an argument, which is the name of the file, policies.csv, and then it's going to run through this function. Then it's going to return the responses, and I'm going to assign it to this variable responses. Then, just to check my work if it's correct or not, I'm just going to print it out and see what I get. Okay, so let's run this and see what happens. And I get back exactly what I expected, which is a dictionary of key value pairs. So here's my first key and its value. Scroll to the right. Here's my second key and its value. Scroll more to the right. Oh, there's location also and its value, and then we have insurance. So now we know that we are reading in the right file. So far so good. Let's go back here, scroll down. So there are a few components to explain here. Okay, so basically this is the same code again, just as above here, but now they just have some comments to explain what each one does, each line does. All right, so I've already explained that part to you. All right, next challenge is rewrite your chatbot code. All right, so let's go up to our latest and greatest chatbot code from last. This is it, right? Yep. Okay, so click anywhere. Control A, Control C, scroll down to the challenge cell. Okay, click here, paste it. All right, so we pasted the code below. And use the code above, which is this code here, to replace the dictionary with a new function called load responses from CSV that takes that input file name and opens that file as a CSV and returns a dictionary of its input. Then call that function later to generate the dictionary you use for responses so that your chatbot operates using the data from the CSV file. And to check if it works, see if it can handle the request insurance, which is a policy that only exists in the CSV file. All right, so we need to basically not have responses here anymore because we're going to be calling it from the file. So let's get rid of this. And then I'm going to come here. I'm going to, well, I need this function here. I'm going to import also the pandas line. So I'm going to copy that, come down here, paste it. So now I have this. And next it says replace the dictionary with a, yep, that's what we did. Then takes the file name, yep, that's what we did, and open the file. All right, so, okay, actually I also am going to need this file, or sorry, this line, copy it, because I want to call it, I want to call this function. Let's paste it down here. So what I did here is I copied all this, pasted it, and I also copied this. I didn't need to copy the print statement because I don't want to prove to myself that I am getting the correct file anymore. But I do need to run this line because this is the line that's going to call this function. And I'm going to call it at the very top because I want to load all the policies into this code cell so that it's ready to be used with the rest of the code down here. And is there anything else we have to do? Call the function. There, call that function later to generate the dictionary. Yep, so that and we did that. Check. Okay, so let's run this code now and see if it handles what we want to handle. So the text line still says vacation, contact, location, or exit. It doesn't say insurance, but we know that we have insurance in our policies file, and we should have loaded the policies file because we have this code function call. So let's do insurance, spell it correctly, hit enter, and let's scroll down in the output. And there we go. Details regarding your insurance policy can be accessed via your pay portal. So it looks like it worked. And just to confirm that we can still get the other ones, let's do contact, hit enter. Yep, you can see the output correctly down here. And let's exit, and it exits. So far, everything worked. Okay. All right, so here it says then, you know, it's nice to have the data now in a separate file and not part of our code, but for policies still isn't many. What if we wanted to add a new policy without having to edit the CSV file directly? So instead of me going into the CSV file, opening it up, and then adding a new key value pair, I want to be able to do it programmatically from within my code. So the code below writes a new policy to the CSV file, and it's about paternity leave. And let's test it. Well, let's first try to understand what it is. So we're going to import the pandas. I have a variable called file name. It's equal to policies.csv, which is the file I'm going to work with. Then it has a variable called keyword, which is equal to paternity, and a variable called response, which is equal to this. Then we have a function defined called write new policy to CSV. And it takes 3 parameters. It takes the file name, which is this guy here. It takes keyword, which is this, response, which is that. Okay. Then it's going to create a new policy, and it's going to create it in a dictionary format. Again, why is it dictionary format? Because our data is going to be stored as a dictionary, and it's using the braces, and it's using the key value pair option. Once we created the new policy, then we are going to create a new data frame and pass the new policy information into this data frame. So now that we have a data frame with this new policy in it, then we're going to call that data frame and then call the method of the data frame called toCSV. So before we had a method called readCSV, which read data to populate the data frame. Now we already have a data frame with the data populated with this new policy, but now we want to go the other way around, which is send that data in the data frame to a CSV file. And that CSV method, toCSV method takes a few arguments. First of all, well, what file do you want to send the data to? What mode do you want to use? Because there are different modes, and the A is for append. Append basically means you want to add the data to the file and not overwrite. For the header argument, we're going to use false because I don't want to add any header information, meaning the column title, which is right now keyword and response. I don't want to touch that. I want to keep that the same. And then for the index, which is, remember, 0, 1, 2, 3, 4, and so on, I don't want to use an index because I want to use the keyword as my index. So that's the function defined. And then we have a function call, because without this function call, this function is useless. No one's going to call it. No one's going to use it. So here I have a function call. I'm going to call this function by its name. I'm going to pass it the expected 3 arguments, which is the file name, the keyword, and the response. And these are defined up here. Okay, so when I call this, file name is going to be policies.csv, keyword is going to be paternity, and response is going to be this. So all this data is going to run. It's going to call this function, then it's going to execute these 3 lines of code. What this should do is it should open up my policies file, and then it should add these 2, well, not these 2, but this 1 key value pair. It's going to have a new line for policy, a new line for paternity, I'm sorry, and then comma followed by paternity leave is 4 months, so on and so on. So let's test this out and see what happens. Okay, I get a check mark, meaning that everything ran. There's no errors. So let's double check our policies file. And there we go. Let me just expand it a bit, enlarge it. And paternity has been added to this. Alright, so now that we've verified this part works, let's move on to our final challenge. So the final challenge basically says rewrite your chatbot code below using the code above to write a function called write new policy to CSV. So basically we want to be able to update our code to use this latest functionality here so that we can add new policies without having to modify the policies.csv file directly. So I'm going to go back to my latest code, which I think is this one. Yep. Click anywhere, Control A, Control C, scroll down to the final challenge cell, click and paste. And then I want to go to this code here and I want to select all of it and copy it. And come down here. I'm gonna erase import pandas and paste over it. And now I don't need keyword and responses anymore. I don't need these two lines because I'm going to basically use the code, which is this function here, to create my own new policies. Okay, now that we have the function defined, it says here we have to update the handle request function so that if a user writes new policy, they are asked for a keyword for the policy and the description of the policy. And then the write new policy to CSV function is used, which is this guy here, to add the list of policies in the CSV. So we have the function here, but we need to update the handle request. So we have an if request is in responses and elif request exit. I'm going to add a new elif, and I already wrote it. I'm just going to paste it here just for shortness of time. So I have an elif request is equal to new policy. Okay, then I'm going to collect a new input from a user by prompting what is the name of the new policy. I'm going to save that to a keyword variable. And then I'm going to prompt them again, what is the response? I'm going to save that into an answer variable. Then I'm going to call the write new policy to CSV, pass it the file name, which is defined up here, and then file the keyword, which is defined here, and then pass also the answer argument, which is defined here. Okay, and I need to move this, get rid of it. Alright, so importing pandas, have this. These are the function definitions. I could actually move this as well so it's not kind of hidden between the different functions. Put it down here. Alright, so up here I just have all my functions. Here's the function, here's another function, here's another function, here's another function. And then I'm going to call this line of code, which is going to load all the policies into a dictionary. And then I'm going to call chatbot, which is this function here, which calls handle request, which runs this. So everything looks good so far. Let's run this. Okay, let's try just testing the regular stuff. Vacation, scroll, yep. Okay, now let's try new policy, hit enter, and there we go. What is the name of the new policy? Let's say policy 7, hit enter. What is the response? Good. Let's say response is blah blah blah, and hit enter. Okay, and now let's exit, and let's double check our CSV file. There we go, policy 7 has been added. Okay, and let's also test it. Policy 7, scroll down, and there we go, response is blah blah blah. Okay, let's exit, and we are done. So for the submitting part, just make sure that you submit the Jupyter Notebook file and also the link by using the share option so you can get the link as well. Some of you were having some issues using the policies.csv file in Google Colab. I used VS Code, so that was me working locally on my computer. So the files were local on my computer that I downloaded from the website. With the Google Colab, this is an online environment, so you are working in the cloud. So here's how you can do this workaround. So I'm going to scroll down to where we start using the files. Okay, so if I try to run this, alright, so I get an error that no such file directory policies.csv exists, okay, which makes sense. So I need to upload this policies.csv file to the Google Colab environment. Okay, right now I have it on my local computer, on my laptop, but Google Colab doesn't know my laptop. So for me to upload this file to the Google Colab environment, I need to go up here to these icons. At the very last one here is the files icon. I'm going to click on it. Under sample data, I'm going to expand this. Okay, right now I don't see anything. But if I go up here, and this is the upload files, so I'm going to click on this icon. And then I'm going to navigate. Now this is my local computer, so I'm going to click on the file that I want to upload, which is the policies.csv. This is just a warning. Say OK. All right, now the policies.csv file is part of my Google Colab environment. All right, so now if I run this code again, it sees it. Okay, now just please make sure though that in my week 6 video I told you that this file is not properly formatted. I think if I double click on it, it opens up, will open up eventually on the right side here. Okay, so I guess that's not the best way to open it because I don't see the double quotes. But if you open this file locally, initially you will need to update the double quotes for all the different values. So if you make any changes to the policies CSV file, you're probably going to make them locally on your computer. But to see the changes in the Google Colab, you have to re-upload the file again. All right, so for example, here I have, just for testing purposes, I have vacation. Okay, now if I go to my downloaded file, all right, and let's change this to vacation 100, hit enter. Okay, I'm going to save it. Now this is only saved locally. All right, so if I go back to my Google Colab and run this again, vacation hasn't changed. Okay, because while I changed the file locally on my computer, those changes were not uploaded to the Google Colab. So then I need to come up here again and then re-upload the file again. So this is the updated file. Okay, now if I run this, now I see the changes. Okay, so anytime you make a change locally on your computer, you have to upload the updated changes again to the Google Colab. Okay, so I hope this was helpful. Please let me know if you have any questions, and I'll see you guys in class. Take care, and bye for now.